Hello everyone, in this video we will be playing Pokemon and we will try to do RNG manipulation on Pokemon Showdown. So we will try to crack the RNG and then predict all future random calls. And as you can see right here, I'm using the move Metronome a lot, because before we can crack the RNG we first need to gather information about the RNG, and the best way to gather information about the RNG is to use the move Metronome. And once we have used the move Metronome 9 times, we will be able to crack the RNG using a program I wrote. So here I wrote a small Java program where you will insert the Metronome results. So for example, in the first turn, the result of Metronome was the move Headbutt. And in the second turn, it was the move Superfang. And once we have 9 more metronomes, we will just insert all these metronomes into this program and then run it, and then it will crack the RNG. And after that, we will be able to calculate all other RNG results. So in this video, we basically ask the question, can we predict the RNG of Pokemon Showdown? And the answer we give to this question is yes, but it comes at a cost. You need to use the move Metronome 8 to 9 times in a battle, and after you can do that, you can predict the RNG of Pokemon Showdown. Okay, we are now at the point where we have 9 metronomes, so we can now get out our Metro Cracker using the lattice algorithm from Matthew Boland, and we need to insert all the metronome results, but we also need to know how many random calls happen between the metronome results, and that's so I will now go through the battle log and we will try to figure out how many RNG things were in there. Headbutt is a normal attack which has a 30% chance to flinch, so it's an attack with a secondary effect. And attacks usually do 3 random calls, but if they have a secondary effect, they do 4 random calls when they hit. When they don't hit, they do just 1 random call for accuracy check. So after the first metronome, we got 4 random calls. And then at the beginning of turn 2, we get another random call, because at the beginning of every turn there is a quick law roll, which determines whether quick laws will activate this turn in Gen 2 and Gen 3. So we are in Gen 3 right now, so at the beginning of every turn we will have another roll. And the spikes from Scammer, we don't do any random calls, so we have 4 from the Headbutt and 1 from the quick law, so we have 5 random calls. And when we get to the Superfang, and if we now run this, then when it says here result, and when there's a long number, and this is the random seed we have. So if you get the random seed like this, then the Java program will also print out an Excel file in the folder in which the jar file is, and in that folder it will then show you all the random calls which happened. So the first seed which we had before the first metronome was this one, and then we used a metronome and we got this Headbutt, and then after 5 random calls, we got the Superfang down here. And then after we got the Bone Rush, and then we got the Acid Armor, and then we got the Twin Needle down here. And I should explain just what this Excel file shows. So the Excel file shows you the random seed before the first metronome, and then it shows you what the next random seed is if you do 1 random call. So if you have this random seed and you do a random call, then you go to the next seed, and each seed has like a roll associated to it, which is like a number between 0 and 1, and each one also has a metronome move associated to it. So if you do use metronome while the RNG is at this seed, then you get the move Headbutt, while if you do it while it's at this seed, then you do Superfang. And so basically what happened in the game, we had this seed and we used metronome and we got Headbutt, and then we got an accuracy check which was this roll, and then we got a critical hit check which was this roll, and then we got damage check which was this roll, and then we got a flinch chance check which was this roll, and then we had a quick claw check at the beginning of the next turn which was this roll. And to now predict the RNG, we need to first figure out where we are currently. So we have here the Thunder Wave, and then we get the Recover down here, and we get the Splash and the Conversion. Okay. And now we also need to figure out what happened since the conversion. So let me think about how I do this best. Okay, so it's, so we had the conversion. The conversion does a random call to determine which type we get. And that's everything that happened since then. But we will have another quick claw check in a moment. So after the quick claw check, we will be right here. Okay, or let's just do it over here. So the next metronome would be Revenge, but I think the Tyranitar outspeeds us. I think the Tyranitar will be first. So so if Tyranitar, for example, uses a Rock Slide and it hits, then we would use Smelling Salts. But Rock Slide, let's just show this. Okay, so we can now predict what the next Metronome from Blissey will be. We will use Metronome here. Tyranitar will use Rock Slide, and when the Blissey is dead. Okay, not the best not the best demonstration effect right here. And then the Smelling Salt is taken up by the Quick Claw. So the next Metronome would be Bulk. If a Gengar were to use Metronome right now, it would use Bulk Up. But we can actually do something more fun than use Metronome, because Bulk Up isn't the best move. We can actually use a Confuse Ray right now, and then we will have a very long Confuse duration, and the Tyranitar will hit itself. And that's more fun. So like if I use Confuse Ray right now, it will hit, and the Tyranitar will hit itself. Because what happened right here is, we were at this Bulk Up right here. So this is the accuracy check for the Confused Ray. This is the roll for how long the confusion will last. So the Tyranitar will probably now be confused for 3 or 4 turns, because this is kind of a high roll for a confusion check. And then this is the check where the Tyranitar checked whether it should attack itself or not. And if this number is higher than 0.5, then it will hit itself. And then after that, this one is the damage roll for the confusion save hit, which the Tyranitar got. So if we were to do nothing right now, then the Tyranitar would actually manage to hit us. But if we just waste one more random call, then the Tyranitar will actually hit itself again. But let's see, what's the most fun thing we can do right here. We could hit a Thunder, but then the Tyranitar would not hit itself in confusion. We can use Psychic, which doesn't do anything. Okay, Psychic doesn't do anything, but Tyranitar hits itself again. So let's just use a Metronome. Metronome will be Psychic. It doesn't do anything, but the Tyranitar hits itself. So that's funny, right? So this was a Metronome call. Psychic did an accuracy check, and then on this thing, the Tyranitar hit itself, and this is the damage roll. So we should be right here. This should be the Quick Claw roll. So if we do nothing right now, then the Tyranitar will hit itself again. So let's just substitute up right here. And the Tyranitar hit itself again. Okay. So this was the confusion check roll, and this was the damage roll, and this is the Quick Claw roll. And okay, next we have Grass Whistle. I don't know what Grass Whistle is, but it's probably some kind of grass move. So let's just use it against the Tyranitar. So if we do Metronome right now, it will be a Grass Whistle. Let's just see what this does. And the Tyranitar is asleep. So that's nice, right? Because so you can see we can predict what happens. Okay, so the Grass Whistle probably did an accuracy check, I would guess, and then it did a sleep roll check. Okay, this will be a very this won't be a long sleep, because that's a really low roll. So the Tyranitar will probably wake up very soon. And whenever you actually manage to status something, then there will be another useless random call. So we should be down here right now. So if we were to use Metronome again, it should be Sleep Powder, I think. But we could also just hit a Thunder right now, because Thunder has 70% accuracy, so the accuracy check will be successful if this number is less than 0.7, and this is less than 0.7. So we can hit a Thunder right here, and it definitely hits. So let's just do this, and the Thunder hits, and this is just how you can manipulate the RNG. And if you ever forget where you are, then you will just need to use a Metronome to figure out where you are again. So for example, if I don't know how many random calls did actually happen right here, then I can just use a Metronome, and then I will know again where I am. So the next Metronome was Magnitude, so this was this one. And then Magnitude does a random roll for which kind of Magnitude is, and then it will probably do 3 hits, and then we will be down here again. And so the next one should be Bubble. Let's see. Yeah. If you want to win using RNG manipulation strategies, then you need to perform 3 steps. First, you gather information about the RNG state using Metronomes. Then you crack the RNG using the LTCG algorithm. And then third, you use your predictions about RNG to gain advantage in Pokemon battles by, for example, predicting full paralysis or critical hits or rock slide flinches and so on. In this video, we will mostly talk about Generation 3 of Pokemon. The RNG cracking program I wrote works also for Gen 1 or Gen 9. It works for all generations except 2 and 4, because in Generation 2 and 4, Metronomes work slightly differently. In the near future, I will plan to also make a program which works for Generation 2 and 4. It's just not right here yet. In general, everything I do here is quite work in progress. Like, this is not super user-friendly. This is just a proof of concept showing that you can do this, and I will try to make it more user-friendly in the future. Okay, so how does this work? So Pokemon Showdown uses a 64-bit random number generator. So the random number generator has 2 to the 64 different possible states it can be in, and those are all. But if you use the move Metronome 8 times in Gen 3, then each Metronome selects one of 336 possible moves. And if you do this 8 times in a row, then there are 336 to the 8 possible strings of moves coming from the Metronomes. And if you keep the random calls between the Metronomes constant, then most of these possible strings cannot actually happen, because the random number generator has less states than there are possible outcomes. So most possible outcomes will not actually happen, and most possible outcomes will only be caused by a single state of a random number generator. So if you know the string of 8 moves from the Metronomes, and you know the amount of random calls between the Metronomes, then it's theoretically possible to calculate the RNG state from that. Now, I've tried this, and in practice, I most of the time need 9 Metronomes instead of 8, because it seems that the RNG is slightly biased. But that's the idea. You can theoretically do this, and not only can you theoretically do this, but you can also practically do this, because there's a guy called Matthew Boland who did like a very efficient algorithm for reversing linear congruential generators, which is the RNG used in Minecraft seed finding, but it's also the RNG used in Pokemon Showdown and in most other video games. So using this algorithm, if you have enough information, you can very efficiently crack random number generators. And if you want to know how the math works, then you can just watch the video by Matthew Boland about it. And after you crack the RNG in Pokemon Showdown, you can then predict future Metronome outcomes. So like, usually Metronome is a very useless move, but if you actually know what the outcomes of the Metronomes are, it can be quite useful, because then you can use like instant KO moves, or you can use evasion boosting moves from the Metronome, and you can like know when it happens and so on. And you can also predict like rock slide or iron head flinches and so on. That's the basic idea. The random number generator of Pokemon Showdown is actually not faithful to the games which are like on Nintendo DS and so on. In Gen 1 and 4, like in Gen 5 it is faithful, but in Gen 1 to 4 it's not faithful, because Gen 3 and Gen 4 cartridge games actually use a 32-bit RNG instead of a 64-bit RNG. So on cartridge, RNG manipulation is actually much more powerful than in Pokemon Showdown, because in Pokemon Showdown you need 8 Metronomes, while on cartridges for Gen 3 and Gen 4 you would only need 4 to 5 Metronomes, and then you would be able to calculate. So if Pokemon Showdown ever implements a faithful RNG implementation for Gen 1 to 4 in the future, then the strategy will become much more powerful than they are currently, because currently I think it's not really viable in Gen 3. It might be viable in Gen 4 with the Iron Flinch Jirachi, but yeah, I will do that soon and see whether it's viable. Yeah. Okay, but to actually crack the RNG, you don't just need to do the Metronomes, you also need to keep track of the random calls. And currently my solution to that is not very user-friendly. I will just tell you in this video what kind of random calls happen when, but I will also work in the future of making a user-friendly interface that automatically keeps track of the random calls for you, because currently you have to do this manually. Okay, so in Gen 3 there are the following random calls. First, at the beginning of every turn there is a quick claw roll, which determines whether quick claws will activate in this turn. So there's one random call at the beginning of every turn. Then there are random calls for moves. There are some moves which do 0 random call, like Substitute, or like boosting moves like Dragon Dance or Calm Mind, though no random calls. There are moves which do 1 random call. For example, if you use Sand Attack to lower the accuracy of your enemy, it has an accuracy check. Like most one-call moves just have an accuracy check and do nothing else. Or status moves like Will-O-Wisp has 1 random call. Although if it actually hits and burns, then it does another random call. But basically everything which has an accuracy check will do 1 random call, and if it doesn't actually then deal damage, it will do no other random calls. And important exceptions are Nightshade, Superfang, and Endeavor. Those are like 3 attacks which actually deal damage, but they only do an accuracy check and do nothing else. Like they deal completely, like the damage is not random at all, and they cannot crit or anything. When there are 2 call moves, those are mostly damaging moves which bypass accuracy checks, because if you have no accuracy check but you deal damage, then you have a critical hit check and you have a damage roll. So for example, Aerial Ace does 2 random calls. Then most attacks which have no secondary effects, like Tackle, have 3 random calls. They have accuracy check, critical hit check, and damage roll. And then if your attack has a secondary effect, like for example Fire Punch can burn stuff, that's a secondary effect, or Rock Slide can flinch stuff, then it has 4 random calls because it has accuracy check, critical hit check, damage roll, and secondary effect check. And then there are some attacks which do more than 5 calls. For example, if you have a multi-hit attack, you will first have an accuracy check, then you have a roll for how many attacks happen in the multi-hit attack. If it's random, like if it's not random, like if you have, for example, Twin Needle, which always does 2, then there will be no roll. But if it's a random amount of attacks, like Furious Swipes, then there will be a roll for how many attacks, and each attack will not do any accuracy check. It will only do critical hit check and damage roll. And if it has a secondary effect, then it will do 3 random calls. So, for example, Furious Swipes does accuracy check, then roll for how many hits you get, and then each hit does 2 random calls. Yeah. So those are the random calls coming from moves. Then there are some moves which cause additional random calls at the end of a turn. For example, if you use Protect for the first time, when you start using it, it doesn't do any random call, but when it ends, it does do a random call, and that's a completely useless random call. So like these Protect or Endure do completely useless random calls at the end of a turn. Like if you use Protect multiple times in a row, then it also immediately does a random call to tell whether it succeeds. But if you use Protect for a second time and it succeeds, then not only does it do a random call for the success check, but at the end of a turn it does a completely useless random call. And also moves like Fly, Dig, or Dive do a completely useless random call at the end of a turn where you start using them. So if you start flying up at the end of a turn, there's a completely useless random call. So those are those. Then status call, if you get a status like Poison, Burn, Sleep, Paralysis, or Freeze, then there will be 1 useless random call. So for example, if a Gengar uses Will-O-Wisp against you, then there will be 1 random call for the accuracy check, and if it hits, then there's another random call simply because you got burned. Well, while minor status things like Confusion don't do this extra call. Okay. And if a Pokemon starts sleeping or starts being confused, then there's a random call for how long it will sleep or be confused, because that's determined by like a turn counter. And if a Pokemon is paralyzed, confused, or frozen, then every time it will try to do a move, it will do a random call to check whether it got a full paralysis, or whether it fought out, or whether it got self-hit in confusion. And also if you get self-hit in confusion, there's another random call for the damage roll. So those are status calls. Then speed ties are a complete nightmare. So like I will try to make things more user-friendly in the future, but until we have a more user-friendly solution, I would advise you to avoid speed ties at all costs, because keeping tracks of speed tie random calls is really difficult. So speed ties cause another, like if your Pokemon has the same speed as your enemy Pokemon, then there will be another 3 random calls at the beginning of every turn. There will be another useless random call after every Pokemon gets hit, and one useless random call after a Pokemon finishes using a move. So if you use a move and you actually hit the enemy, then there will be 2 useless random calls from speed ties at the end of the thing. And also whenever a Pokemon switches in and there's a speed tie, it does another 3 random calls. And there might be even more random calls happening from speed ties. I'm not sure if I can keep track of all of them. So right now, just avoid speed ties. Also, if you use Metronome to gather information, it can happen that you accidentally use Transform. And if you use Transform, then you get into a speed tie, because you transform into your enemy and you get the speed of your enemy. But there is only you only get 1 speed tie call at the end of the turn. If you're in Sandstorm or Hail, there's 1 extra speed tie, and if you have leftovers, both have leftovers, there's another extra speed tie. And then you can switch out in the next turn, and there will be like only 2 speed tie calls before that, and 3 speed tie calls if you both switch out. So with this you can keep track of things if you use a transform, provided you instantly switch out. So like if you accidentally transform into your enemy, just switch out immediately and then use these rules to counter thing. But okay, keeping track of random calls is currently very difficult, so before you try it out against random opponents and inevitably fail, it's good to first practice it on a localhost server that is modded to print out random calls. So if you want to make a localhost Pokemon Showdown server that prints out random calls, what you do is you go to the GitHub Pokemon Showdown repository and you download it. I will link this in the video description, and then you can just go into an IDE of your choice. So for example, here we have it open in VS Code, and you go into the sim folder, and there's the prng.TypeScript, and in there you can do print statements. Like this is a random number generator from Pokemon Showdown, and if you go to the next function and you just console.log whenever it advances to the next RNG seed, that will help you a lot for keeping track of random calls. And also the metronome will use the sample function. So in the sample I also log what kind of thing got sampled from this. I will not publish this code because this is just Pokemon Showdown plus 2 console logs. You can do this yourself. And after you have done this, you can then start the Pokemon Showdown server by just doing a node Pokemon Showdown. You need to install node, but on Pokemon Showdown we explain how this works. And after you have done that, you can host a localhost server here, and the localhost server will print into the console whenever there are random calls, and with that you can easily keep track of random calls and crack the RNG just for practicing purposes. And once you're very good at doing this, then you can go on the ladder and try to do RNG manipulation there. But I recommend first just doing a localhost server and printing stuff in the RNG class. Yeah, that's at least how I figure out the random calls.